Hey everybody. In class lately we've been doing a lot of work with solving inequalities. Tonight we're going to get a little bit more practice working with inequalities, especially when it comes to word problems. So we're going to start with 3 examples, and we're just going to write a simple inequality for each situation using a variable. Now for each of these problems we always want to decide what the variable represents. For example A, it says a bus can hold at most 48 students. So we need a variable for that. We can use B. You don't need to use B. You can use any variable you want. We can say B equals the number of students on the bus. Okay? B equals students. The number of students on the bus. I don't like to use S because my S's look like 5s. So now we have B, and we're comparing B to 48, right? Now B isn't going to be equal to 48, or it's not going to be just equal to 48, right? Because you could have 2 students on the bus. You could have 10 students on the bus. But we know that we can't have more than 48. So B is less than 48, and since it says at most, it includes 48. We could go up to 48 students. We just can't go any higher than that. So our answer is B is less than or equal to 48. Example B says that to legally fly by yourself, you must be more than 12 years old. So in this case, we're talking about age. Let's use A to represent the age of the person. So the age we're comparing to 12, the age of the person, if they're going to fly, says it has to be more than 12. So A is greater than 12. In our last example, example C, it says that the cheapest flight out of O'Hare Airport is $125. So we're talking about the price of a flight. Let's use P for that. P equals the price of a flight. Now it says that $125 is the cheapest flight. So the price of any flight compared to $125, it's not going to be less than $125. It can't be any cheaper than that. It could be equal to it because it does say that's the cheapest. So that exists. Or it could be more. So P is greater than or equal to 125. So here we have 3 situations we can use inequalities to represent mathematically. In some cases, we can use inequalities to find answers to a question when there might be more than one answer that makes sense for that situation. In example D here, it says a boat lift can raise as much as 3,600 pounds. So that's a boat lift is what picks a boat up out of the water. So it can pick up as much as 3,600. An empty boat on the lift weighs 2,300 pounds. So that's without anything in it. Write and solve an inequality to find the additional weight allowed in the boat without exceeding the lift's capacity. Remember, whenever we are working with a word problem, it helps if we underline what we're looking for. We want to find the additional weight allowed in the boat. So in order to write my inequality, I'm going to need to know how to represent that since I don't know it. So I can use W. We use W to represent the additional weight. Additional weight. Sorry for the handwriting. Now, if W is the additional weight, there's a couple other things we need to know. We need to know that it can raise as much as 3,600 pounds, and we know that the empty boat weighs 2,300. Now, when it says as much as 3,600, that means it could be less than 3,600, right? It could pick up an empty boat, 2,300, or it could pick up a boat that weighs 3,000 pounds. It could also be equal to 3,600 because it says as much as. So it could lift 3,600 but nothing above that. Now to represent the weight of the boat, we know that the empty boat is 2,300, and we know that we're going to have W pounds of additional weight in the boat. So that could be equipment, it could be people, it could be a lot of stuff. But we're going to add whatever additional weight that is to whatever the empty boat weighs. And this total weight right here cannot be more than this. It has to be less than or equal to. So to find the answer to this inequality, we just have to solve it. We draw our line through the middle, or down through the inequality sign. Now I have 2,300 plus W, so we have addition going on here. This is a positive number, so I'm going to subtract. 2,300 minus 2,300 is going to give me 0. So we're left with W on the left side. On the right side, when we subtract that same amount from over there, we have 1,300 left, and our inequality does not change in this specific case. So we say that W, the additional weight in the boat, has to be less than or equal to 1,300 pounds. All right, we're going to do one more quick example. Eric had $7,600 in the bank when he lost his job. If he spends $20 each day, how long has it been if he has less than $100? Now, I'm going to start once again by underlining what I'm looking for. We're looking for how long has it been. Now, this is talking about time, and in this problem, we're measuring time in days. So let's use D to represent the number of days it has been since he lost his job. Now, in our problem, it says that he has less than $100. That's important. I'm going to put a box around that. We know he had $760 in the bank, and we know that he spends $20 each day. That's all going to be important. Now, I know he has less than $100, so I'm going to start off with that. Less than 100. He had 760, so that's what I'm going to start with over here on the left side. 760. And he spends $20 each day. So since he's spending that money out of his bank account, we're going to subtract $20 times the number of days. So 760 minus 20D is less than 100. So now we have to solve this. We'll draw our line. We're going to subtract 760 to start our problem because that's a positive 760. And if we subtract it, that'll give us 0. So now we have negative 20D left is less than negative 660. Now, to undo this negative 20 times D, we'll divide by negative 20. And we are left with D. On the right side over here, we have 33. And because we divided by this negative number here, we divided by this negative number on both sides, we have to flip the inequality. D is greater than 33. That's our last example for tonight. Go ahead, complete your notes, submit it through Canvas, and I will see you guys tomorrow.